DNA purification of a specific size is necessary when we need to obtain a specific band of DNA and is in an agarose gel or a polyacrylamide gel. For example, when we realize a PCR and we observe a band that is of our interest, we need to know the specific and the best method for us to purify this DNA and use it for another reason.
The next type of purification is electrolysis or recovery of DNA in a dialysis bag. For this method, it is necessary to run the DNA in an agarose or polyacrylamide gel and use an intercalating agent. Subsequently, the fragment of gel where the DNA band is cut with a knife and this fragment is placed into a dialysis bag with thin little of buffer. Then the bag must be well sealed and it is going to be inside of an electrophoresis chamber and a voltage of 10 to 15 volts per centimeter for 30 minutes. Finally, when the DNA no longer observed, we are going to see that the DNA is going to be away from the walls of the dialysis bag. Finally, buffer is recovered from the bag and phenol extraction can be done in order to precipitate with ethanol. In this chart, we can see different types of purification, advantages and disadvantages of them. We have first electrolysis or recovery of DNA into a drop of salt. This one is based in the utilization of a camera with a special design that allows the DNA in a fragment of agarose gel migrating to a drop of ammonium acetate salt of 10 molar. The next one is electrolysis or recovery of DNA in a membrane. For this, the DNA sample is going to be separated on an agarose gel. It is going to be observed with a long-wave UV lamp to identify the position of the band we want to purify and cut parallel to the band in the gel. Then we are going to apply voltage until the DNA band has migrated towards the membrane. The membrane we will remove and incubate in a solution of high concentration of salts in order to carry precipitation with ethanol. Another type is hot phenol. For this one, DNA needs to be low melting point agarose. We are going to extract the piece of gel we want. We are going to transfer in a microtube and centrifuge. Then we're going to add some buffer and phenol. The microtube is going to be placed in a water bath at 68 degrees. Then we're going to mix with vortex and expect to have two phases. We are going to centrifuge again and we are going to recover the aqueous phase. We are going to have a phenol with extraction and finally we can precipitate with ethanol and sodium acetate. Then we have purification with magnetic pearls. This procedure consists in using beads that contain a core of steel or a material magnetic attraction. The exterior is coated with a material that interacts with the nucleic acids. So we only need to add them, then make some washes, and finally eliminate the interaction of DNA with the pearls and recover it. Another type of purification we can use is DNA fragment with GTG agarose. We need to know that this type of agarose has been modified and treated for not to interfere in reactions with enzymes. For this one, we can cut the band we want with the help of a long-wave UV light and transfer it into a microtest tube. The next step is to melt in a molten bath at 65 degrees, and once it's melted, it can be directly used in the reaction to be performed. We can also use agarose degradation with agarase. For this purification, we need the agarose fragment contained in the gel to be coated and digested with agarase, which hydrolyzes polymers of agarose and subunits of disaccharides. Then it is purified by phenol extraction and precipitated with ethanol. Finally, we have silica-type columns. This one is going to be the procedure applied in the practice. It's important to recall that silica is a material that has the ability to interact with the DNA under conditions of high chaotropic salt concentration and is eluting if the salt concentration drops.
This practice was based on the purification kit PureLink from Invitrogen. For the protocol was required to place the other sample on a gel and wait for the bands to separate. Then display the sample in the gel with the help of UV light and proceed to cut the band corresponding to the DNA of interest, trying to cut at least amount of gel. The sample of interest will be placed in the sterilized microtube and reserved for further purification. For the purification process, it is necessary to put the fragment of interest on the gel buffer L3 in a water bath at 50 degrees and at intervals of 3 minutes mixed by inversion for 15 minutes. It is then centrifugated. The supernatant is removed, washed buffer is added, and then again the sample is centrifugated and the supernatant is removed. Then elution buffer is added and incubated at room temperature for a minute. Then centrifugate and recover the elutate. One of the most important steps is verification of purity, which is done using two techniques, electrophoresis and the spectrophotometer. With the help of a spectrophotometer is measured concentration and purity of DNA, and electrophoresis help us to see in agar gel if there are no contaminants in the sample.
In the first lane of the figure 2 is shown the gene ruler 100 base pair DNA ladder. And in the second lane, we can observe our PCR product purified from a 0.8% agarose gel. We can see that the sample shows some degradation, but it did migrate to the expected length. Using the spectrophotometer at 260 nanometers, the absorbance index taken was 0.002, and the concentration of the sample was 0.1212 micrograms per milliliter. In a ratio of 260 and 280 nanometers that was taken, the value obtained was minus 1.4892.
As we saw in the results of the spectrophotometry, there was a negative observance, and in the electrophoresis we obtained the expected result. So, why negative values? There are many options for that. One is that there was an incorrect collocation of the cube sample, or maybe the equipment was wrong calibrated with a sample instead of a blank. But the thing that we think that really happened is that the cubes were put in the sample were contaminated or poorly washed, because they are the same that we dealing in other practices. Or it could be because we use the positive control instead of the sample. These are some reasons of we have obtained a negative value in the observance of the spectrophotometry.
As we have seen, after this practice, we did a purification for DNA from an agarose gel. We obtained our DNA, we ran it in our gel, and we saw our bands with different molecular weights. We obtained negative absorbances and a concentration of 0.1212. Finally, we can see that even when we got some negative numbers and we thought it wasn't good, we saw that our purification was good and we obtained the product we wanted.